Hi, today we're taking a look at Unit 3, Lesson B, Exponent Quotient Rules. Our objective for this video is that you can divide powers that have the same base and you can find the power of a quotient. So let's start with our first rule for today, the quotient of powers property. And here we have this problem and it says a to the fifth divided by a cubed. So let's take a look at what this looks like when we write this out without exponents. A to the fifth can be written as a times a times a times a times a. And then this is all over a cubed, which can be written as a times a times a. Now, let's think about what happens when you have something that's both on top of the fraction and on the bottom. We can cancel those things out so that those a's can cancel out, these a's can cancel, and these a's can cancel, and that leaves us with two a's on our numerator. And if we were to write that with an exponent, we can write that as a squared. Let's look at what we started with. We had a to the fifth divided by a cubed. Our exponents were 5 and 3. What did we do to turn the 5 and the 3 into a 2? We subtracted. 5 minus 3 gives us 2. So our rule for today is that when you divide, you subtract the exponents. Make sure you're writing that in, that we're subtracting it. So let's take a look at some examples. Our first example is 8 to the 10th power divided by 8 to the 4th power. So here we have the same base. So again, our key here is that we're looking and making sure that we have the same base. You can only subtract those exponents if your bases are the same. So our bases are the same, so our answer will have the same base of 8, and then we'll subtract our exponents. 10 minus 4 gives us 6. Now the directions just ask us to simplify. They don't ask us to evaluate, but if you were asked to evaluate, let's add that on here, and our answer would be 262,144. All right. Our next problem here, we have a base that has negatives. So remember from our last video that we have to be really extra careful when you have those negatives. So here our base, both in the numerator and the denominator, is -3. And notice that that -3 is in parentheses. So when we write down our answer, we're going to put the -3 in parentheses. And then we'll subtract our exponents. 9 minus 3 gives us 6. And again, if we multiply that out, we're going to get 729. And again, your directions don't ask you to evaluate. I'm just taking this a step further. Next problem. Here we have 5 to the 4th times 5 to the 8th, and this is all over 5 to the 7th. So we're going to put together a rule that we've learned in the last video in the numerator here, where we're multiplying together two of things that have the same base, and when we multiply those two bases together, we're going to add those exponents so that that will become 5 to the 12th power over 5 to the 7th power. Now we can do our division, and we have the same base, so we'll keep that same base. We're going to subtract our exponents, so 12 minus 7 gives us 5. So we end up with 5 to the 5th power, which is equal to 3,125. All right, now let's take a look at some examples, and we're going to throw in some variables now. So our first problem is x to the 6th divided by x to the 4th. Same base, so the base stays the same. Subtract your exponents. 6 minus 4 gives us 2. Our next one, we have 1 over x cubed times x to the 8th power. Now we have a multiplication problem here that involves a fraction. So before we do anything, I want to take that x to the 8th and write it as a fraction. So I'm going to put that over 1. This is going to emphasize for me that this x to the 8th is in the numerator and the x cubed is in the denominator. When you're multiplying fractions together, you multiply across. So we'll multiply our numerators. 1 times x to the 8th is x to the 8th. And multiply your denominators. X cubed times 1 gives you x cubed. Now we have a division problem, x to the 8th divided by x cubed. The base is the same, so we'll write down our x, and now we'll subtract our exponents. 8 minus 3 gives us 5. And here we don't have any evaluating to do because our base is just a variable, so our answer is just x to the 5th. So next you see some you try problems, so we're going to save those for you to do in class. And let's scroll up here to our next rule. And this is called power of a quotient. So here, notice in parentheses, we have some variables that are being divided, and then outside the parentheses, we have an exponent. So this is similar to a rule that we saw in that last video when you take that outside exponent and you apply it to everything inside of the parentheses. So we can rewrite this expression to be a to the m power over b to the nth power. So everything in the parentheses gets that outside exponent. So let's see some more examples using that rule. So number 11, we have x over y raised to the 3rd power. So everything inside the parentheses is going to get cubed. So the x is going to get cubed and the y is going to get cubed. And here we can't simplify any further because the bases are different. We have different variables, so we're just going to leave that. That's our final answer. Our next problem, we have negative 7 over x squared. Now before we do anything, notice that negative is written out to the side of that fraction. I want to take that negative and apply it to either the 7 or the x. I always apply it to the numerator. So let's rewrite this problem to look like this. Negative 7 over x, and this whole thing is being squared. I like to do that because if you don't, then sometimes that negative sign gets lost and we don't want to lose that negative sign. So we need to be extra careful when we have those negatives. So this negative 7 is inside of the parentheses, which means that the negative 7 is going to get squared and the x is getting squared. And we can simplify negative 7 squared. That becomes positive 49 over x squared, and that's your answer. All right, moving on to 13. Here we've got a little bit more stuff going on inside of the parentheses, but still the same idea that everything is being cubed. So even the 4 and the 5 are going to get cubed because those are inside the parentheses. So let's write this out like this first. The 4 gets cubed. Now the x squared gets cubed. So now we need to remember that rule from the last video that when you had one base and 2 exponents, you'd have to multiply those exponents. So 2 times 3 will give us 6. Then in our denominator, our 5 is going to get cubed, and the y also gets cubed. So let's clean this up a little bit more. We like to multiply out the 4 cubed. So 4 cubed is going to give us 64, and then x to the 6th. And in our denominator, we can multiply out 5 cubed. That gives us 125 over y cubed. Now with these coefficients, the 64 and the 125, you always want to look to see if you can reduce that. It's the same thing if you just had the fraction 64 over 125. You would look to see if you can reduce that. Here though, we can't reduce 64 over 125, so we're going to leave that as our answer. But always look to see if you can reduce. All right, moving on to number 14, we have a squared over b, and the whole thing is being raised to the 5th power. So let's start with the a. We have one base, 2 exponents, so that's our rule where we have to multiply our exponents, so that gives us a to the 10th. And then the b in the denominator gets raised to the 5th power. And that's it for that one. Not so bad. All right, let's turn our page. And we've got just one more problem to look at. Example number 3. This is asking us to identify, describe, and correct the error. So this is an error analysis problem. So let's take a look at what we started with. So we have this problem, 9 to the 5th times 9 cubed over 9 to the 4th. So if we go to the next step, looks like the denominator stayed the same. And in our numerator, they changed the exponent to an 8. So let's see if they're correct. We have 2 of the same base, so our rule says to add the exponents. 5 plus 3 gives us 8, so that's good. So far we haven't found a mistake. Let's move on next. So now we have a division problem. So we have to remember when you're dividing, we have to subtract those exponents. So 8 minus 4 should give us 4. Uh-oh, here's our mistake. Is this 12? There's our error. What it should be is 9 to the 4th power because 8 minus 4 is 4. So we have identified our error, that this 12 is incorrect. Let's now describe our error. And the error was that the exponents were added instead of being subtracted. So we'll write that down. I want to write all that down to have the correct answer. And then lastly, it asks us to correct the error, which we did here, and the answer should be 9 to the 4th. Alright, so that's the end of this video. Nice and short and sweet, so make sure you're filling out the bottom what you can do after watching this video, and also make sure you're marking down what you can't do, and make sure if there's something you don't know how to do that you're asking those questions in class so you can have those questions answered.